we're going to talk today about, this is our prerequisite part 2, R2. We're going to talk about X and Y intercepts, circles in standard form, and symmetry, graphically, algebraically, and Pythagorean Theorem. So guys, when we talk about intercepts, X and Y intercepts are where the graph crosses the X and Y axis. All right, like an interception in football. You know, the defender crosses over the route, intercepts the ball, runs the other way. We don't like it. An intercept is where the line will touch the X and Y axis. At those values, one of the values of the coordinate point is 0 because it's actually crossing the axis. So if you're trying to find the X and Y intercepts, you plug in 0 for the opposite thing. So what I mean by that is if I want to find the X-intercept, where the graph crosses the X-axis, what number am I going to plug in for what? If I want to find where it crosses the X-axis, I'm trying to find a number, I'm going to plug in 0 for Y. All right, so if I'm trying to find the X-intercept, I plug in 0 for Y. That means I'm going to have a number, comma, 0. And then we're just going to solve. What this problem looks like is it says x squared minus 9 equals 0, correct? Okay, we'll fix that one sec. So I have x squared minus 9 equals 0. How do I get x by itself? Okay, plus 9 to both sides. Thank you, we'll fix that one sec. So x squared equals 9. And then how do I get x? Take the square root. When you physically put the square root on, your answer should have what in front of it? Plus or minus, good. So your x-intercept is going to be at positive and negative 3, 0. You can write it like that, or if you want to, you can write 3, 0, negative 3, 0. Make sense? Yeah? Okay, let's look at the next one. We're going to do the same exact thing, but instead of finding, I don't want the eraser. Okay, so if I'm going to find the other intercept, instead of plugging in 0 for y, I'm going to plug in for x. So I have 0 squared plus y minus 9 equals 0. Well, what is 0 squared?
0.
0. So I have y minus 9 equals 0. What do I do with 9? Add to both sides. So I have an intercept at y equals what? 9. And I would write that as an ordered pair as 0, comma 9. Andrew just pointed out we have a little bit of a typo up here. To find the x-intercept, you plug in 0 for y. And then to find the y-intercept, you plug in for x. No worries. All right, let's look at the second one. Again, if we're going to try and find intercepts, if you guys don't remember, you're like, oh, I can't remember what I'm supposed to do. Watch. Just actually physically put a 0 right here. So in an ordered pair, where did I just put the 0 for what letter? Y. So look, it's right here. Don't get yourself hung up on, wait, I can't remember how to do this or what I'm supposed to do. Let's change this 4, change it to an 8. It'll make this problem a little easier. So I'm trying to find the x-intercept here. Do you guys see that? So I have negative x cubed minus 8 equals 0. Well, what do? I get 8 to both sides. So I get negative x cubed equals 8. How can I get rid of that negative x cubed? Okay, if I divide both sides by negative 1, I have x cubed equals negative 8. And then what do I do with a cubed? It's the opposite of cubing, cube root. So if I take the cube root of this side, then I take the cube root of this side. So x equals, what number times itself 3 times gives you negative 8? Negative 2, good. So it's just negative 2. How come I don't put plus or minus? Because it's a cube root. If it was an even root, you have plus or minus. It's an odd root, so you just have 1. So your intercept is at negative 2, comma 0. We're going to find the other intercept. Instead of plugging in 0 for y, I'm going to plug in 0 for what? Okay, so 0, comma something. So I have y minus 0 cubed minus 8 equals 0. Well, what's 0 cubed? 0, so just cross it out. What do I do with the 8? Plus 8 on both sides. So where's my intercept here? At 8. So what we're finding, guys, is if you were to graph this cube root, which looks like a snake, if you guys remember, is going to cross the x-axis here at negative 2, 0, and it's going to cross the y-axis at 0, 8. Make sense? Okay, let's scoot. What do you guys notice about this one? There's no x. So what do you think that means about the x-intercept?
0.
No. That what? It doesn't have one. It does not touch the x-axis. So this would be no x-intercept because it doesn't even have an x in the problem. It does not touch the x-intercept. Anybody know what this looks like? Y squared? What's that shape?
It's like a U, I think.
It is. It's a parabola. Good. It's a U. Where does it move since it's minus 9?
Down.
It would be if it was x squared minus 9, it would move down. Since it's y squared, it's going to move left and right. It's turned over. But don't worry about that. I just want you guys to know shape. Shape. If we're squared, it's a quadratic, so it's a U shape, up or down. That minus 9 moves up, down, left, right, those sorts of things. But let's plug in. If I want to find the y-intercept, that means I plug in 0 for x. There is no x, so don't worry about it. So I just have y squared minus 9 equals 0. So now what? Okay. That might have messed up my video. We'll see. We're going to add 9 to both sides. See if y squared equals 9. Then what? Square root. Since I physically put the square root on, what do I write? Plus or minus. Good. So my intercepts are at 0, 3, and where? 0, negative 3. Again, if you guys do this problem, and you get all the way to the end, and you forgot to put plus or minus, is the entire thing wrong? No. But if you don't show me work, I need to, then, then that's not good. Okay, moving on. Here's the equation of the circle. You guys did this in Algebra 2. We talked about this. X, Y are constants, like in y equals mx plus b. This is the equation of a what? Slope-intercept, equation of a line. Your y and your x stay. Like if I had y equals 2x plus 3, you guys would tell me the slope is what? 2. The y-intercept is 3. Okay, so in this case, same thing's going to occur. Your x is a constant, your y is a constant in the formula itself. Your center is at h comma k. And it's always the opposite of what you think. Meaning, we'll show that in a second. And then your r is your radius. So if it's r squared, that means you have to do what? Take the square root. So let's look at this. The reason I say it's the opposite of what you think. The formula, it has a minus inside, correct? So if I'm looking at this and I say, guys, what's the center of this circle? I would tell you it's at 1, 6. And you're like, but it says negative 1 and negative 6. The formula is x minus and y minus. So if I plug in a positive 1, doesn't that look like the formula or like your problem? Right here? It doesn't? This doesn't look the same?
Yeah.
Right? If I had a negative, if this was x, say they told you the center was negative 2, comma negative 4, I would say x minus negative 2. Well, what's a minus a negative? Positive. That's why it changes. Because in the original equation, or formula, however you want to look at it, it is a negative. So it's the center is always the opposite of what you would think. Because the original equation has a negative sign. So, say it again.
If they had both positive, would it be
Negative, negative. Mm-hmm. So look at your radius. In our equation of a circle, whatever number's at the end is our radius squared. So you tell me what the radius is. What's the square root of 9? 3. Now, I told you before we're doing intercepts, if you put the house on, then you need plus or minus. But in this situation, why does a negative 3 not make sense? Distance. Very good. You're talking about the distance from the point on the circle to the center, so it's not going to be a negative number. So let's go over here. Again, there's our equation. What is being added or subtracted to x? 0. Very good. And then what is my y coordinate of my center? -7. Very good. And then what is going to be my radius? Perfect. Once you guys remember this, you're like, oh, can we have 25 of these in the quiz? All right, what's my center here? Perfect. -8, +5. What's my radius? It's the square root of 20, right? If you guys left it like that, am I going to say, oh my gosh, congratulations, that's perfect? No, what do we have to do? We got to simplify. Break it down to a perfect square and a non-perfect square. What perfect square and non-perfect square is in 20? 4 and 5. So what's the square root of 4? 2. So your radius is really 2 root 5. That makes sense? You guys good? Okay. Moving along. All right, now we have to write the equation of a circle given the center and a solution point. That just means a point on the circle. So let's remember what our equation of a circle is. It's going to be x minus h squared plus y minus k squared equals r squared. What information do we already have? We have the center. So I have x and my y part of the center. What is the x part of the center? It's going to be +2 in the equation because my equation is minus a negative. Minus the negative gives me a positive. And then what's the y part? Just -6. How would I figure out what the radius is? They didn't tell me. Look, here's the center. Did they give me the center?
Yes.
And they gave me a point on the circle? How could I figure out how far it is from here to here? What's that formula we talked about yesterday? The distance. So let's just do the distance formula real quick. Get it all set up like yesterday. So I have -2, 6, and I have 3, 1. Does it matter if I measure from the middle to the outside or from the outside to the middle? No. Just put your x's with your x's, your y's with your y's. So what are my x values?
2 and 3.
-2 and 3. And then what are my y's? 6 and 1. Great. So guys, what's -2 minus 3? -5 squared. Plus, what's 6 minus 1? So I have 5 squared. 25 plus 25? Am I done? No. If I simplify that, and again, some of you are going to be like, well, you don't have to. I'll show you why in a second. But if I simplify that, I need a perfect square and a non-perfect square. Think about money. 25 and? So my answer would be 5 root 2 for my radius. So if I was going to go back and write the equation of my circle, I already know it's x plus 2 squared, and it's y minus 6 squared equals what my radius was squared. Agreed? Mm-hmm. Well, what's my radius? What did I just find it out to be? 5 radical 2. Okay, so if I plug 5 radical 2 in here, and it has to be what? In the formula, it's radius what? Squared. Does anybody know how to simplify that?
Doesn't the square cancel out the root?
The square does cancel out the root, agreed. But that 2, that little square, does it go to just the root? No, it goes to the 5 and to the 2. So this would be 5 squared is 25 times 2, which is 50. So if, in this case, the only time you can keep your radius unsimplified, if I just left it here, right, at 50, and I plugged it in my formula as squared, what would have happened?
It would cancel out.
The square and the cancel would cancel out. The square and the root would cancel out. But if I were you, I would get into the habit of simplifying, and then go backwards, because then you guys are gonna start questioning, well, wait, do I have to simplify in this part, and do I not have to in this one? So it's just get in the habit of just doing it. But does that make sense? You guys okay? So my final answer would be x plus 2 squared plus y minus 6 squared equals 50. Alrighty, moving along. Does anyone remember, just even thinking about it, graphically and algebraically, how to find symmetry? Nobody. Okay, let's talk about it graphically. That's the easier one. Graphically, if something is symmetric, if I have my coordinate plane, if it is symmetric to the x-axis, which one's the x? Horizontal, left and right. I can fold it over the x, and it's going to be on top of each other, perfect, like a mirror. If it's symmetric to the y, I can do what? Fold it over the
x-axis.
to the y.
Oh.
If it's symmetric to the origin, there's something that you guys have to remember with symmetry to the origin. Sometimes it's really hard to look at and see, but if something is symmetric to the origin, it has to go through what? Has to go through, if it's symmetric to the origin, it has to go through the
X. Zero.
it has to go through 0, 0. It's got to go through the origin. So if I gave you a picture and I was like, is this symmetric to the origin? Right away, your answer is what?
No.
Because it doesn't do what? Go through. Okay, that's important. In order for something to be symmetric, you have to be able to fold it over. So it's easy to visually see on a graph if you can fold it over the x and y. Algebraically, it's a little tougher. Now, depending on who you had for Algebra 2, teachers teach it differently. The proper, mathematically correct way is to plug in a negative y and a y, or a negative x and an x, or a negative x and a negative y. I understand that. A lot of you guys don't. It gets confusing. So what I tell you to do is pick a number bigger than 1. Don't get too crazy because you're going to have to do stuff with it like square it and all that. But pick a number bigger than 1, 2, 3, 4, and its exact opposite. So let's look at this first problem right here. I'm going to figure out if this is symmetric to the x-axis or symmetric to the y-axis. Okay? You're going to plug in negative y, positive y, that sort of thing. It's going to be like, wait, what? Did I get the same thing? What I want you to do, I'm going to pick 2. And I'm going to pick negative 2. So if I plug in positive 2 for x, I get 2 squared plus y minus 9 equals 0. Agreed? Okay, so what's 2 squared?
4.
Plus y minus 9 equals 0. Now what?
Plus the 9.
Can you combine 4 and 9? Okay, so y minus 5 equals 0. Now what? So y equals 5. Agreed? Okay, let's go over here and do the same thing. If I plug in negative 2 for x, negative 2 squared plus y minus 9 equals 0. Why did I put negative 2 in parentheses? Because that's what that number is what I'm putting in for x. It has to be in a hug. You got to hug it. If it's negative, it feels bad about itself, so you got to give it a hug. Put it in parentheses. But what is negative 2 squared? 4 plus y minus 9 equals 0. Okay, so simplify. Y minus 5 equals 0. So y equals what?
4.
Did I get the same answer when I plugged in a number and its exact opposite? That means it's symmetric to x. I plugged in the same number and its opposite for x, and I got the same thing. That means when I graph it, if I get the same thing on the positive side of the graph and the same thing on the negative side of the graph, what can I do? I can fold it. It's going to be symmetric. Sometimes it's easier to use numbers than letters. If you guys plugged in negative x there, you might get a little confused. Don't try and confuse yourself. Just plug in a number. It doesn't matter. You can use 3, you can use 12. I don't care. People like to get funny and be like, I'm going to use 100. Okay, fine. If you want to square 100 and do all that, Doesn't make any sense to me, but whatever. So we found out that was symmetric to the x. So now what do you think? How do you think we figure out if it's symmetric to the y?
No, you do the same thing.
You're going to do the same thing, but instead of plugging into x, you plug in where?
Y.
Perfect. So pick a number.
4.
Okay, 4. 4 and negative 4. So I have x squared plus 4 minus 9 equals 0. So over here I have x squared plus negative 4 minus 9 equals 0. So x squared minus 5 equals 0. Agreed? Yeah? X squared equals 5. Okay, on this side I have x squared minus 13 equals 0. So x squared equals 13. What do you notice? They're not the same. So that means on the positive and the negative side of the graph, do these graphs look the same?
No.
So is this symmetric to the y?
No.
Nope. So how do you think I would figure out if it's symmetric to the origin? What does it tell you to do up here in the notes? It says to plug in negative x and negative y. You're going to pick a number and you're going to plug in negative x, negative y, and then a positive x, positive y. Just like a mirror image. So let's pick a number for x. 2, okay? Y equals 3. Just arbitrary numbers, doesn't matter. Those are the ones I'm going to use. So that means I have to use x equals negative 2, and I have to use y equals negative 3 as well. So my original problem was x squared plus y minus 9 equals 0. So let's do x is 2 and y is 3. And then over here, let's do x is negative 2 and y is negative 3. Is this problem long? Yeah. Is it crazy hard? No. So if I plug in over here, I have 2 squared plus 3 minus 9 equals 0. What's 2 squared? So 4 plus 3 minus 9 equals 0. What's 4 plus 3? 7. And 7 minus 9? So negative 2 equals 0. Is that a true statement? No. Let's come over here. Negative 2 squared minus 3 minus 9 equals 0. What's negative 2 squared?
4.
Minus 3 minus 9. What's 4 minus 3?
7.
Nope. 4 minus 3.
1.
1 minus 9. Negative 8 equals 0. Is that a true statement? Do you think this is symmetric to the origin? No. So if they ask you algebraically to prove if something is symmetric to the origin, you have to do all three. Or if they say if there's symmetry, you got to do all three. If they say to a specific axis, then you only have to do whatever they ask, or to the origin. But if they do ask you to do all three, you got to do all three. It takes just a little bit of time. It's not crazy, ridiculously hard. It's just kind of time consuming. Let's look at the next one. Exact same. Actually, let's do C, because that's the exact same problem that we just did. I want to find out if it's symmetric to x, symmetric to y, symmetric to the origin. Is it symmetric to the x-axis? How do you know? There's no x. Good. Let's see if it's symmetric to the y. Pick a number. Somebody say 8. Let's pick something other than 2, just for fun. 5. Okay, we'll do 5. 5 and negative 5. So I have 5 squared minus 9 equals 0. And then I have negative 5 squared minus 9 equals 0. What's 5 squared? 25 minus 9 equals 0. What do I have over here? 25 minus 9 equals 0. What's 25 minus 9? What is it? 16. What do I get over here?
16.
Now, if I was looking if this was symmetric to the origin, what would we do? We would say no, because it's not a true statement. Did I get the same thing on the left-hand side, the same thing on the right-hand side? Yes. So is this symmetric to y? Yes. When you work this out, what you're looking for, God bless you, is the same thing on the left-hand side as the right-hand side. if it's symmetric to the origin, then it has to be a true statement at the end. We'll practice these more, I promise. You guys will see this more and more. On Monday, we're going to have a review before your quiz, so I'll make sure that we go over these, because these are the ones that get a little hairy. I understand that, but I'm just...
How do you find the...
Oops, forgot to record. Okay, Pythagorean Theorem. Guys, everybody remembers the Pythagorean Theorem. A squared plus b squared equals c squared. These problems are long. This problem you'll tell me, I can just see if it is or isn't. That's great. I need to see your work. It says to do what? Prove. That means you have to show me. Use the distance formula to determine the length of each side. Then use the Pythagorean theorem. So the first thing you're going to do, let's look at A together. Let's graph it. Plotting points. 1, 5. So I'm going to go over 1, up 5. 1, 2, 3, 4, 5. Then I have 1, 1. So 1, 1. And then I have 4, 1. 1, 2, 3, 4, up 1. Okay, can you guys plainly see that this is a right triangle? Yes or no? Since I can count on my vertical and horizontal axis, you guys could tell me that the distance from 1, 1 to 1, 4 is how many? How far is it from 1, 2, 3, right? All right, how far is it vertically from one point to another? 1, 2, 3, what? 4. I don't mind if it's on the vertical or horizontal axis that you guys count. That's fine. But you do have to use the distance formula. I don't want you to use the Pythagorean theorem yet. That's just at the end to check. I want you to find the distance from this top point up here, from this point here to this point there. We know the distance formula. Let's do it. What points am I looking at? Which two? 1, 5, and? Okay, so I have 1, 5, and 4, 1. So what are my x's? 1 and 4, so 1 minus 4 squared plus 5 minus 1 squared. Agreed? So I have negative 3 squared plus 4 squared. 9 plus 16. Square root 25. So how long is this? 5. So now it says prove. You have to find the distance from all three sides, which we did. And now we're going to use the Pythagorean theorem to prove that this is a right triangle. What is the Pythagorean theorem? A squared plus b squared equals c squared. C is always our what? Hypotenuse. Some of you guys are going to say, well, I can't tell what's the hypotenuse. The hypotenuse is the longest side. So just plug in your numbers. I got a 3, I have a 4, and I have a 5. Agreed? 3 squared is 9. 4 squared is 5 squared is. Does 25 equal 25? Yes. So you guys just proved to me that this is what? This is a right triangle. It's correct. So what I would need to see in this situation is that you can tell me the distance from all three of the sides. If you can count them, great. If not, no big deal. But then you have to plug it into the Pythagorean theorem. I got one more problem and then we're done. Promise.
Can I see that?
Of course. All right. Last one. Let's plot the points. So I'm going to go 2, 7. So 2, 1, 2, 3, 4, 5, 6. I can't count. 1, 2, 3, 4, 5, 6, 7. 0, 0, and then 3, 5. 1, 2, 3, 1, 2. Okay, this one's a little harder to see. Are any of my sides on the vertical or horizontal axis that I can just count? No, so that means my problem's going to get a little longer. I have to do the distance how many times? 3. It doesn't matter the order that you do it in. I just need to see the distance between 2 points, and then another one between another 2 points, and then the last one. So the first one I'm going to do is right here, between 2, 7 and 0, 0. So between 2, 7 and 0, 0. It's kind of easy when we have the origin. What are my x values? 2 and 0. So 2 minus 0 squared plus 7 minus 0 squared. Okay? So I have 2 squared plus 7 squared. 4 plus 49 gives me what? Square root 53. Do I have to simplify this right now? No. If you wanted to try or whatever, you could, but I don't have to, because all I'm trying to do is just prove that everything is a right triangle or not. So just leave it like that, because in our Pythagorean theorem, what are we going to plug in? Square root of 53. And what are we going to do to the square root of 53? We're going to square it. So it's just going to cancel out anyways. So now let's do another distance formula. And we'll do from 0, 0 to 3, 5. Okay, so 0, 0, 3, 5. So I have 0 minus 3 squared plus 0 minus 5 squared. So negative 3 squared plus negative 5 squared. 9 plus 25 is what? Square root of 34. Okay? So I have two sides right now. I have square root of 53, square root of 34. And then I have to do one more. So I'm going to do from 2, 7 to 3, 5. Everybody with me? Okay, so 2, 7 to 3, 5. So I have 2 minus 3 squared plus 7 minus 5 squared. Negative 1 squared plus 2 squared. 1 plus 4, so root 5. All right, so these are the three sides that I figured out. Have I proven to you that this is or is not a right triangle? No. So now I have to use what theorem to do that? The Pythagorean. Good. So when I plug in, my Pythagorean theorem is a squared plus b squared equals c squared. Some of you are going to say, well, which one's the hypotenuse? The hypotenuse is the biggest number. Good. So plug in for a and b, either root 34 or root 5, doesn't matter. So I'm going to have the square root of 5 squared plus the square root of 34 squared equals square root of 53 squared. Boys, I'm going to pick on you right now. Some of my girls do this, but not usually. Some of you boys be like, I can already tell. It's not okay, that's fine. Take the extra step, finish the problem, so you can show me from beginning to end that this is or is not a right triangle. If I square a square root, what happens? Cancel. So 5 plus what? 34 equals 53. 39 equals 53. Is that a true statement? No. So is this a right triangle?
No.
So your answer would be not a right triangle. Am I going to give you 5 of these to do on a quiz? No. This is not a hard question. It's just long. There's lots of places to make silly mistakes because there's a lot of math in here, like little stuff. But that's it. Okay, so that's a lot of you, like I said,